Yeah, sure. I was gonna like just overall. Uh, I'm blanking, but like I remember there is some trigonometry about sun and like overall just I am curious about stuff because there are many different displays of flat Earth. I
Yeah,
guess that's the
yeah,
word because I have seen like the what's the thing where people think that there's like a bowl-like thingy. I'm forgetting the word for it because I'm sort of tired. Uh,
yeah,
uh, uh, but and they think that there's like far lands, like kind of like yeah, that model as well. Yeah,
yeah,
thank you, whoever that
yeah.
fence. Yeah, I'm gonna call you fence because it sounds fun. Yeah.
So, right. So there are many different conceptions about what the Earth might look like since it's measurably flat. And so some people have done some really silly things. They've taken a globe, and the globe is actually a polar coordinate reference system where they measure the celestial sphere, which is the concept of the stars being spheres around the Earth, which would in this case would be a flat plane. And the celestial sphere is an official thing. It's used for navigation and the ephemeris. They've been around forever, but these are just concepts. Well, they took all the points that they measure on the surface of the flat Earth, and then they turned it into a coordinate system called a polar coordinate system or a polar projection. That's the globe. That's actually not the map of the Earth. That's a celestial sphere kind of turned inside out. So the inside out celestial sphere then got splayed out into what's called the azimuthal equidistant projection. And that's the one that most flat earthers seem to like, and I don't know why, because it's very easy debunkable, like you can disprove it really simply because it's a projection of a globe. The only point of it is really that the latitude lines are accurate, or excuse me, the longitude lines are accurate, and they give you the correct positions of the sun over their regions for the most part. That's what that's for. For no other reason, that's just trying to help you know where the sun is at in relation to the uh, the land masses. Okay. Now, the idea of there being we call the people who think there are more lands beyond the ice wall on the azimuthal equidistant projection, which is just silly. We call those people outer ponders, where they think there is more water and more land beyond Antarctica or whatever. Also, really silly because there's really no evidence for that and there's no way to prove it. So that's a bad idea. There's also the cartoons and the propaganda that's been shoved in everybody's faces for I don't know how many centuries about a disk Earth kind of floating out in space. Nobody here believes that. Or, like a snow globe floating out in space. Nobody here believes anything like that. It's all kind of absurd. So there is no real uh, model or we'll say visual aid to help you understand what the Earth ultimately looks like. All we can tell you is that measurably it is flat. What the sky is doing and how it does it, we don't actually really know. It's all kind of a mystery. What the limits are to this realm, I have no idea, and I don't know where to go to find those limits. So it's a very interesting thing. But what I can tell you is that everybody measures the Earth flat.
Yeah, and this all sounds like cool and all. I'm sort of always forgetting the points because, flat Earth is kind of like a thing that I've just been skimming. Is that the right word to use? Like skim, like you take
Yeah,
in like
yeah,
slowly in small
yeah,
bits.
yeah. That's
Uh,
the right word.
yeah, but like it's always fun because I've been getting onto this, I guess, from the globy side, if I
Sure.
use that nickname. It sounds silly to use it like vocally, but aside, back to the point, like I've watched all the mainstream stuff like I'm and Dan and Kevin Dubé and all those guys who are just basically
Okay.
just going like, no, you're wrong, no, you're wrong, and just
We're
over.
kind of an exception. because we tend to focus mainly on the geometry aspects and try not to entertain too
Yeah, I
much
know they're kind
the
of silly, and I
speculative
like the
regions
silliness.
of the whole thing.
Yeah. So the Simon Dans and the Professor Daves, those types, the Dave McKeegans, these are people who are really attacking all the silly flat earthers, but they don't really deal with the stuff that we're talking about. Navigation, measurements, those are the things that we discuss here. They're taking care of some of the more conspiracy oriented, esoteric whack jobs. Those are the guys that they're debating with. They don't come over here. They don't talk to us. They don't like us. It goes really bad for them really quickly. So um, we want them to come over. It would be highly entertaining. But no, they don't really talk to us too much.
Well, yeah, and that as well, and they're the loudest, so that's who you see, I guess, because
Sure.
loud or
Yep.
like quote unquote loud. They're the I'm forgetting the word for it. Like what was my original thing I said about like trigonometry and the sun? Like
Right.
what are the like given distances of like no? Because again, I come from the silly arguing channels, but I have never like done this speaking thing before because kind of never found a place. But they seemed fun. Oh,
No, you sound pretty good. If you haven't spoke a lot, your English is pretty good. Now you're asking about trigonometry. I didn't want to get off the trigonometry. What specifically were you talking about in regards to that?
Uh, yeah, I guess like overall, when again, I am not fully uh, incorporated into like what kind of flat Earth we are doing in here, but like the main thing I've been seeing argued is like, oh, why can't you see this building from here, or like
Yep.
the sun's position and all that? Like, is it called the equinox? Like when it's nearest to the equator, like people measuring that as well.
Yeah, I think the is it the vernal equinox is the one that we decide true east and true west, right? So when the sun rises and the sun sets, at that time of year, when the sun is between what we call the tropics, the Tropic of Capricorn and the Tropic of Cancer, middle of the year, right? As far as we can tell with the stars and the sun, that's what we call the vernal equinox. So yeah. Now the angular relationship to the sun that the Earth has, and how we measure it, and even how we use it to navigate, that all is using a flat Earth to do that. You're using the baseline of the triangle as the surface of the Earth, and you are measuring a distance, an angular distance. And I know that's kind of hard to, maybe that's not the best way to describe it, but the angular
No,
height or the elevation. Yeah. So the angular
Yeah, it
height,
is
the
an
elevation angle,
angular length. Yep.
angular length, yeah, is
Or
is
height. Yeah,
using the
yeah, you're
Earth
right.
as the
Yep.
right, using the Earth as the flat baseline for that, and the GP or the ground position of the sun is at 90 degrees to that baseline. So you get an elevation angle that could be, fairly shallow or fairly acute, where let's say it's 20 degrees. Well, that 20 degrees might end up making the GP of the sun, the ground position of the sun along that baseline, a few hundred, a couple thousand miles away. Because you're multiplying, you have to subtract the 20 from the 90, and then you multiply that times 60 nautical miles. Well, that's 70 times 60, right? So that's, what is that? 6,300?
did you say 20 times 60?
Yeah, 20 times 60, excuse me, not 20 times 60. So 1,200, excuse me, 1,200
Yeah,
miles, right?
1200. Yeah. Yes.
1,200. I don't know why I got confused. I was multiplying 70. Yeah, 20 times 60, that's 1,200 miles. So that's 1,000 miles of flat Earth that they just measured. They know that they are 1,200 miles from the GP of that star. across the surface of the Earth. That's a flat horizontal distance. So then, if they're doing this, they also create circles of equal altitude. So you take that 1200, that would be the radius of that circle, and so 360 degrees, right? You can pi r square that and get your area, and that's dozens of thousands, I think, tens of thousands of well, it might be more than that. I'll have to do the math of flat Earth. That big circle that you just created under the GP of that star, it's huge. It's a huge area of flat Earth. And that's how they get their position, because they will measure multiple stars and then they will get their ultimate distance based on that angle to their location, and they'll kind of triangulate themselves in between those GP positions of the stars that they're measuring. You can use the sun, and I think there's oh somewhere around 60 other navigational stars that they use, so they can always kind of get a good idea of where they're at, especially at night, right? Because you can use the stars at night, can't do that during the day. So that's how they figure out their position, and that's all flat Earth, and that's all measuring the Earth flat.
Yes, that sounds like making sense. But like
Mm-hmm.
also way I have seen people like implement trigonometry during the equinoxes. Like during the equinox, the sun is expected to be between the what was the word, I forget,
The tropics,
the
the
two
the
tropics.
tropic of yeah. Mm-hmm.
Yeah, so on the equator it would be about 90 degrees up would be the sun. Yes,
Yeah.
that's correct.
So on that day, at what we call the equator, right in between the tropics, because those are the 2 points on the Earth where the sun is at its highest in the south and highest in the north. So right in the middle, that's what we would call the equator as well. That kind of follows that path.
Yeah.
Although, if you look at a globe, the analemma, if I'm not mistaken, does not cross. If you know what the analemma is on a globe, it does not
No,
cross
I
the
would love to
equator.
know.
Yeah. So our equator ultimately is a big elevation angle to Polaris, because Polaris is the only star in the sky that doesn't move. So that's what we call north, the North Star, Polaris. And the elevation angle to Polaris at 0 degrees, essentially, where you get your equator. There's a lot of interesting things about the equinox and the equator, that are a little bit off, a little bit goofy, which doesn't help the globe out any either. These are just measurements that we take, but yeah, it's very interesting if you start to break down all the claims about the globe and how it's supposed to work. And there's a good bit of it that doesn't quite add up. Some things are very egregious, some things are small. The biggest thing is that the Earth is not curving.
Was that all? Like, yeah, I'm gonna go back to the. I get this angles. Yeah, but like that explained like a lot of like what I don't know about flat Earth, I guess. But like, uh, and like the words that I'm using because I'm not a native. So yeah.
It's fine.
But like I remember the measurements. Like trigonometry is a very simple math, but I just don't remember it all the time because you have your sine, you have your cosine, you have your tangent. Yeah. So basically, with just two angles and a flat-ish measured distance between the equator and a city directly up north or down south from that
Uh-huh.
decided upon a position, that gives you one side and two angles of a triangle, yes? If you want to measure to
No,
the side. Oh, I'm sorry.
no, no, no. Are you talking on a sphere?
No, I think it would do that on a flat Earth as well. Yes.
Well, yeah, if you're measuring angles to the sun, they have to all be straight lines, right?
Uh, yeah.
Yeah. So the Earth is going to be flat when you measure an angle to the sun.
Well, I guess there would probably be math that I don't remember to make it work on a globe as well, but like on a flat Earth, the math would be easier.
Well, if you're not going to beg the question, do you know what begging the question is?
Uh,
It's
I think I
it's
do.
it's assuming that the premise is true within your argument. Okay, so if you say I'm going to measure to a tangent point, well, a tangent point is a point where a straight line meets a sphere. So when I say tangent point, I'm already assuming that there's a sphere or a ball involved, right? So instead of begging the question or calling what I'm measuring a tangent point, what I'm going to do is I'm going to measure an angle between the Earth and the sun and myself, right? So uh, all three legs of that triangle, all of those angles are straight lines. That's the only way you're going to get an angle to an object in the sky if you're using the Earth as the baseline for your angle. Otherwise, I don't know how you're going to get an angle necessarily to the object in the sky if the Earth is a sphere, if you're drawing to a tangent point, because then it makes things a lot more complicated.
Yeah, I'm sorry. I don't remember what the sin, cosine, and tan mean. I just remember that you can use them in trigonometry, so that's on me, I guess.
Right. So, what
I
is your
don't.
ultimate point? Are you talking about the
Well, yeah,
how?
I guess my ultimate point is just like, would the like, I guess just the position of the sun, I guess is my ultimate point, and like, yeah,
You mean the
and
height of it?
yeah, the height of it compared to the
Okay.
Earth. Yeah,
All right. So
just
the
this.
actual height of the sun is completely unknown. We have attempted, right, to use trigonometry to figure this out. And the number is somewhere in the ballpark of like 3,100 miles high, 3,100 miles high. That's one of the numbers that I've heard. But that is not accurate, and that's not correct. Because when we take elevation angles from the surface of the Earth, no matter what height we're at, we always get the same angles, which means that it's a nonlinear relationship, and that what we're seeing as the sun might not even be a physical point or a point in what we call, some people call it free space, a point in free space that can actually be measured too. So it would appear as if the sun is in an apparent location, meaning, well, I can see it. It looks like it's this amount of degrees high up off the surface of the Earth, but I cannot do the rest of the formula to get its actual location. The sun is doing kind of weird things when we try to measure it. Same with the moon. The moon also does a lot of weird things when we try to measure its actual height. And we're starting to think, or at least this is my opinion, you don't have to think of this as anybody else's opinion other than mine. But I don't think that the sun and the moon, at least where we see them at, are physical objects. That's just me.
Also, are there like from mirror or refraction? Yeah, I have heard that as a
Yeah,
speaking point.
right.
Sorry,
So
there's my browser. There's my search engine. I'm fixing it. Yeah, I'm looking for a map because I can't remember how it. Uh, like from what I think, like, can't you just, like, I'm not trying to beg the question because I'm just legitimately not too smart, but uh, like if you have 90 degrees at the equator to the like approximately directly under the apparent sun, and then you have
Yeah.
a distance from that point to a city or just any spot directly south or north, that gives you a side, yes, and then you go to whatever place you have chosen as long as it is direct and it doesn't stray west or east. Yeah, those are the directions.
Hmm.
So wouldn't that then, if you go to that position and you look at the sun, like I guess you would have to lay down, like let's not think about that. Like then wouldn't you have a second angle? So you could use trigonometry on both flat Earth and a globe, but on a globe I can't remember how it would work. But I do remember like I don't remember then even in my own language because I mostly study this or quote unquote study this in English, but like refraction is one of the words that I remember and like all that fun stuff, which is apparently
Right.
messing with the measurements you're getting. Um, I'm gonna let you speak because I have been speaking way too long.
No, it's fine. So here's the thing with your hypothetical scenario, right? So let's just say that the sun is at 90 degrees above you on the equator. Okay, great. So you have a 90. You have a vertical or zenith. In celestial navigation, they call it the zenith, but it's a 90-degree perpendicular relationship with the Earth. Now, if you say you want to go to a distant city in the south, well, the first thing you're going to have to figure out is how do you get that distance? So I would ask you, how do you find the distance between the equator and the city? How would you do that?
Well, you could either, I guess, if like I do trust the like measurements that I'm given, but I guess you could do it manually, which would be a pain in your butt. But
Yeah,
like, you know, I haven't done that, so I'm not gonna ask you to do that.
right. That's kind of my question. So somebody gave you a distance. How do you think they got that distance?
Well, somebody must have mapped it, but then again, most maps do probably assume, as you have said, assume globe.
Well, actually, it turns out that all maps that we have are globe projections. So the celestial sphere that I was telling you about earlier, and the way that they turned that inside out and then wrapped that around a sphere and called it the Earth, um, that is not the Earth.
Figures.
That is the
I
celestial
hate
sphere.
figures.
Oh boy. Anyway, we have trolls that come through all the time because they see that we're live streaming, so
Oh,
we'll
I
have that
see.
every once in a while. Yeah, yeah. But anyways, so the distances, even on the globe, are not 100% accurate. The distances between points are not as accurate as you would think because even the globe itself, I don't think has a linear scale for distances on it. So accurate distances are pretty tough. The Mercator is a little bit better. That is a projection of a globe where they um, basically take all the points and kind of plot them on a cylinder, and then they open that cylinder up, and that's how you get the Mercator projection. But the actual distances between points, especially long distances, are kind of best guesses for our practical purposes. The actual distances are not known. And the only way they really get those distances is elevation angles, and that's with a flat Earth.
Yeah. Oh, that's
What I'm
actually
trying to
nice.
say is all of the distances that you're going to get on a globe or any kind of map are usually using elevation angles between points. So They're always measuring the Earth and the distances from point to point on a flat on a flat plane. That's how it works. And then they reify that into the celestial sphere. Oh boy. Who's got a hot mic? Who's deciding to just be rude for no good reason?
Yeah, but that's actually very well messing with me because, like, it's basically your point that all the numbers that we have are made by, untrustworthy people. So, like, we don't know the actual like distance from the equator to Cairo or equator to Helsinki or equator to London or.
No, the true distance I would tell you is probably not known. I think we're close, but because all of the maps are projections and they all come from the celestial sphere, that these distances are best guesses and are good enough for practical purposes. It's really difficult, believe it or not, it's very difficult to get accurate distances between points, even on the small scale, right? And we have
Oh yeah.
things like range finders and lasers and stuff, and those are helpful. So we go from point to point to point, trying to measure as best we can, and we do it in small sections. Those are good ways to find, distances if you want. But the bigger the distance gets, the more your accuracy kind of deteriorates. And so even then, there's really no way for us to actually know. I'm certain, and this is just me, but from city to city or whatever, we're not accurate within even, I would say, yards. I'd say it's probably dozens of yards or more with our accuracy. And as those distances grow between the cities, that margin of error increases. So by a good bit, we might be miles off in certain situations or dozens of miles. Now, this is just my opinion, but it's pretty doggone hard to get distances, especially over the water. The water really makes it tough.
Yes, definitely. But I have found like maybe a measurement between the equator and Cairo. That's what I used, of like 3,330 kilometers approximately. So imperial, it would be 2,072 miles.
Okay.
So I don't remember how to do trigonometry, so that's really hasn't. It had,
Yeah.
yeah,
Well,
yeah. The sub is absolutely correct. If that was about like my measurement.
okay. Well, the measurement that you were using. So, did you use like Google Maps or Google Earth? What'd you use?
Uh, Basically, that's the first answer.
The Google Earth.
No, the first answer which I got, which is a very bad compilation of an AI, which is I don't like
Okay.
that it's integrated. I don't like that it's integrated, but that's what it says.
Right. So they're claiming that it's 3,000 whatever kilometers
Yeah,
from the equator to
3,350.
Cairo.
Yep.
3,350. Okay. So 3,350 to Cairo from the equator. Okay. There's their claim. Now, how do you think you and I would be able to validate that? I'm not saying that they're necessarily inaccurate, but the question is, number one, how did they get that distance? And number two, do you think you and I could prove that in any way?
Well, yeah, I guess as an individual who probably doesn't live anywhere near Cairo, except if some of us does, I wouldn't know. Or does it matter because where you live is private, I guess. But like uh, I guess we wouldn't have, and we just have to trust the number that we are given, since I am a very gullible person personally, and like I will trust people if they say something. Like, why would a person lie? And
Yeah.
yes, I do understand that people are scummy at times, and people do also
Hmm.
make mistakes, which is reasonable.
Sure. No, listen. We get that question a lot. Why would people lie about this particular thing? Okay. And I'm not even saying that that question isn't valid, because usually about the time that you suspect that someone may have lied to you, you kind of want to know why, right? So it's not an invalid question, but it won't ultimately help us get to the bottom of the main question, which is, where do we live? You know what I mean? If I really want to know whether or not I live on the Earth, or on a flat Earth, or on a ball, I'm going to have to just forget about why I would be getting lied to. I just have to go with how it measures. And then I can ask the question, why did you lie to me? Not why would they, but why did they? Now, that question, once again, hard to answer, because I have to know people's motivations. And if I don't think I can sniff out their motivations, divine their thoughts, then I'm still going to be barking up a tree after a squirrel that ain't in it. So um, it's better just to kind of stick with the facts. And then if people realize that they have been lied to, and they want to speculate about why they're getting lied to, that's up to them. I just prefer, and I tell people this all the time, I just know in this case how not to get ripped off anymore, not how not to get scammed. So if I'm being scammed on a very large scale, which this would qualify, I think, um, then I don't have to keep listening to the people that are scamming me, and I can be very, I can scrutinize, or I can challenge and be a skeptic of all the information that I take in from these sources. These sources just so happen to be most of the major governments. And shocker, most of the major governments on the surface of the earth, well, they're pretty scummy, and they do lie. And their motivations usually have to do with power and money. I mean, it's not that hard to figure out. But you would go, well, how do they get power, and how do they make money on this lie? Dude, they make a ton. Not even just on NASA T-shirts, but on the ad revenue from movies, TV shows, books, magazines. I mean, it's endless. The amount of money made on just the entertainment side of the heliocentric paradigm, or the heliocentric idea, is enormous. There's tons of monetary incentive. The
NASA
power
has
is
a
that
huge studio,
you're
and they
scared,
rent
right?
NASA has a huge studio they rent out for Hollywood productions all the time.
Perfect.
And the best way to keep control over a populace is to make sure that they are not very well informed, and that they're always scared. That's how masters treat their slaves. Pretty simple.
Yeah, I do guess I have tried looking up the numbers, and I have found a trigonometry calculator of
Okay.
sort. So I have just been feeding the numbers. I apparently do not have the right to stream my screen on this server, because I probably haven't verified in some way. So I will just do the math. I have given in the distance to. Actually, I will just screenshot this if I do have the right to send pictures. So, it's a very simple setup of, you have the triangle, and then you have all three sides, and no, I cannot send the picture. But you know how a triangle would be shown in trigonometry pictures. I
Yes.
cannot send the picture either.
Right. What are we trying to figure out?
Yeah.
What are you
So
trying to find out with your trigonometry?
Yeah, so I have, well, I guess the height of the sun right now, which was my original point,
Yeah.
which I am amazed that we have strayed this far, but it's fun because, conversation.
Right. Well, you will get a number, okay? If you try to do trigonometry, if you have an elevation angle of the sun, and one of the distances that you think, between the equator and Cairo, let's say, is accurate, then you're going to be given a number if you use that function of trigonometry. Now, how do we validate that number? So if it gives you a number for height in miles, or in this case, it'd probably be kilometers because you're using kilometers. If it gives us a number, how are we going to verify that?
Uh, I would say more trigonometry, because on both a globe and flat Earth, if one of the numbers is inconsistent, it would probably mean that something went wrong, right?
Well, so the idea of the distance to the sun, according to the globe, is that they are measuring angles at 2 times of the year on both sides or both ends of the ellipse, the oval orbit around the sun. And this is all presupposed, by the way. The size of the Earth is presupposed. The circuit or the ellipse around the sun is presupposed or based on that radius. The size of the sun and the distance to that is based on an assumption that Venus, being a planet in outer space, is roughly the same size as Earth. And then they use Kepler's third law of orbital mechanics to find this out. So these are all presuppositions, not measurements of any kind, to give you that
I hate
93 million miles. I understand, bro. What else?
Oh, I thought you were talking to the other
No,
person.
just
Yeah.
more trolls. So these are all presuppositions to give you 93 million to the sun. Now, the first thing that we would have to establish, if any of that is going to be accurate, that 93 million miles, is if the Earth is curving, which is why we always ask people when they come in here, and this is a question for you, who measured the curvature of the Earth? And can we verify those measurements?
I do not know nor remember if I have been told who was the person or the group of people possibly who measured the curvature. Yeah, that's the word. Yeah, I forget it even though you said it 2 seconds ago. God damn.
That's okay. Yeah, you're learning, man. Listen, if you've learned this much English, where are you from? What is your native language?
Finland. We learn like Finnish, Swedish, and English by norm. So
Okay, yeah.
Do you know Ismo?
Which Ismo? Oh, the comedian. Yes.
Yeah.
Yes.
Right. So it turns out we've been looking for this information. Well, since this resurgence of the flat Earth has popped up here, it seems like it happens at the turn of every century. This was a very highly debated topic, or very popular topic, early in the 1900s. Now it's back, and so we've been scouring the internet because apparently, even though I know that not every document and not every source is going to be on the internet, it's a pretty good library. There is no evidence that anybody has actually measured the curvature of the Earth ever, not once. It's always been a calculation based on a few pre-assumptions, but never a measurement. So there is no measurement of the curvature on the surface of the Earth, nor is there any detected. And that means that if there is no measurable curvature, then the Earth cannot be a ball. And if the Earth cannot be a ball, the entire heliocentric model, the idea, the concept with all the math, is thrown out the window. It is just a concept. It's all based on a presupposition of an Earth with a certain size as a ball. Once that's taken down, everything else falls with the house of cards. And that's where we're at. There's never been a globe. It was only an idea.
Objection, Your Honor, speculation.
Yeah, I sent pictures to Sidu because they are nice and they will probably send them into the chat. Thank you. I didn't notice that, so my apologies.
So the Busta, this is not a speculation. It's fact that no one has measured any Earth unless you can show me some.
Asta? Me?
Yeah.
No, I didn't join to discredit you.
Well, you said speculation. I'm telling you as a fact that there are no actual Earth curve measurements. Oh, okay. Well, if that's not a speculation.
I'm sure I could pull some measurements up. That shouldn't take me too long.
Okay. Now, all I need is a measurement, and hopefully it's something that's verifiable by us. Give us the method, right? All that stuff. So,
Who's
you know that
this
you're gonna
guy
follow
who's
me.
going to make some measurements?
what?
Who's the guy that was about to make some measurements?
Well, I was
Who was the guy?
saying it's speculation because I bet I can pull up some measurements.
Great.
Please correct me if I'm wrong, but is geodesic surveying not taking into account the curvature of the Earth?
So
No, in fact, they're measuring the Earth flat, and then they're taking those flat Earth measurements, and they are wrapping them around a presupposed ball. So those would be flat Earth measurements that you're going to show me.
So yeah, they assume that the Earth's flat, but that's because it seems to be flat.
No, they don't assume it. They measure it that way.
It says geodesic surveying treats the Earth as a curved surface.
Oh, it does. Okay, so you can tell me then how they're getting angles to points along a curve. I'm sure that'll be real easy.
It's something to do with the triangle adding up to more than 180 degrees because it's wrapped around the 3D.
Says who?
Oh, so it's wrapped around a ball that's presupposed. That's why it's more than 180 degrees, and then it's not a triangle. So you don't have a triangle. You don't have the curve. It's only presupposed. I need you to go ahead and measure. Yes, I know. Hey, bro, do you think you can shut the hell up? I don't know why you're talking over me right now. I don't get it. It doesn't make any sense. I just need you to just shut up, dude. I'm talking to somebody.
Inebriated.
Anyways, if you're going to measure angles to points along the surface, then you have to have 3 straight lines. There's no way it's not going to be a triangle. If you have a measurement where you have a triangle that adds up to more than 180 degrees, well, then number one, it's not a triangle, and it's not a good measurement, and it's not going to help you, you know?
No, but it's right. So please forgive my lack of mathematical literacy, but if you wrap a triangle around the globe, you can have a triangle with 3 right angles.
Right.
That's
So
just,
number
I'll pull
one,
up the picture if you need to, but
I already know what it is. It's a PZX triangle. Number one,
there we go.
you can't wrap the triangle around something that you've presupposed. I need to know where the globe came from in the first place. Where was the Earth curve measured?
I don't have specific measurements, but I'm happy to get back to you and see. I'd imagine you've already got a debunk for it, but
No, I mean, the debunk is that there are no measurements. Everything that is measured is planar. They measure the Earth as a plane, and then they take all of those angular relationships to the distance that they measure, you know, height, like elevation angles and then depression angles and the distances in small sections. They take little squares, and then they take those little squares and they wrap them around a presupposed sphere like a giant disco ball. You know what a disco ball is?
yeah, I'm aware.
Yeah, okay. So you take all those
I'm
little
not that
squares
stupid.
and put them around a sphere. And some people don't know what a disco ball man is. I'm not trying to
Well,
demean
it's in the
you.
name.
Some people, oh, well, I know, but some people don't know what disco is. I'm dealing with young people. Sometimes you sound like you're a little older, whatever. But so that ball part is the part that we're struggling with. And that curved triangle, I think you'll understand. So when you take something that is straight on all 3 sides, and then you try to place it on top of a spherical object, you're going to have to bend the lines, and that's when you get the bending of the lines. So what they said is, oh, well, we've got just a couple of measurements where, you know, we couldn't quite get the triangle. And I think the reason that we couldn't get the triangle is because we're on a ball. Well, that's circular reasoning. In reality, these surveyors always get a triangle because that's what they need for an accurate measurement. And then when they place it on the ball, they have what's called spherical excess, because now it warps the triangle, or it warps the square, and then you have what's called spherical excess. It's after the fact. The thing that we're looking for is the measurement of the curvature of
I've
the
just put it in
surface
the
of
chat.
the Earth. Yeah, right. So, like I said, I've already seen this, bro. And it's not a debunk.
Yeah, I thought
If they didn't get a triangle, did they make an accurate measurement?
I'm sorry, I
Um,
was so sucked into the conversation. I must go. It is 1 in the morning. I didn't notice.
Okay, man. Come back anytime.
Yeah. Thank you for the conversation. It was very fun. I'm sorry that I couldn't prove my point, but the very nice cider, they sent my maths for flat. So yeah,
Okay.
do with it as you wish. I must go now.
Okay. Right. So we have triangles that aren't triangles. And so just because we have, in my estimation, bad measurements or just an inability to get a triangle in a couple of situations, why are we assuming that's because of Earth curve? When if we measure the surface of the Earth directly, there is no curvature.
well, can you link measurements that display zero
No,
curvature?
I did. Well, you posted it. You gave me these measurements here. These are all planar surveys.
But would that not show the curvature of the Earth? I mean, I didn't look at it, to be honest. I was just trying to help you out.
Oh, no, it's fine. So you gave me the measurements that I need. These are
Yeah, no, I
measurements
didn't.
of the surface of the Earth. It's all triangles. And those triangles, right? The baseline of a lot of these triangles, especially when doing planar surveying, is straight, flat, horizontal.
Yeah. Okay, well, let me be honest. I don't have a fucking clue about the measurements, the physical, mathematical measurements of the Earth. What I can say is I've looked into this stuff, and there's a lot of things that don't align with the flat Earth model. Not that you claim to have one.
Sorry, what flat Earth model are you talking?
Well, that's the issue. If everything aligns with reality, everything of the flat Earth, shouldn't you have a pretty succinct working model right now?
That's a good point. We've been looking for a globe Earth model, and there isn't one of those.
Well, heliocentrism, I'd say that works pretty well.
No, I've never seen it. Where's the model at? Can you show it to me? And all the predictions and the things that it are accurate about it.
Well, yeah, it predicts the celestial bodies,
Well, just
equations
post it.
of gravity. I'm
No.
surprised
Post
you're
it.
asking me, to be honest.
Yeah. I'd like to see this model.
Well, a model that predicts lunar eclipses. That doesn't make much sense on
yeah.
flat Earth.
I don't understand do you have a model that can show us how the Selenelian lunar eclipse works?
Selenelian is that's just refraction, is it not?
So it's refraction. Okay, well then I guess it's incumbent upon you to prove to me that refraction can bend light, or actually it's going to be bending
Well,
a
we know
shadow, so it is occulting the moon upside down, while both the sun and the moon are above the surface of the
Yeah, we
horizon.
know that refraction bends light. For example, if you
No, we
track,
don't.
no, we do, because if you track the sun going
Okay.
down with a camera, for example, like you track the speed, the sun will appear to descend below the eye line of the camera because it's appearing to rise up due to refraction when it enters a more dense medium.
Okay.
So we know
No
that it bends
problem.
light.
Can you get me the test where they could accurately, predict how the light will behave in the medium across the distance that you're describing to me? Instead of just making the claim that because we have this thing over here that happens, sometimes it's because of refraction. It's kind of like a baseless
Well,
assertion that you're making. So
no,
what I need to know is, how did they test this so that we can see that light, which by the way is not a string or a piece of wood, how light bends? It's photons.
but we literally know that it does. We can prove this. We can
Great, then
demonstrate
do
it
it.
scientifically.
I'm just Go ahead.
Are you denying that refraction bends light?
No, I'm not denying anything. I want you to show it to me. I would be denying it if you showed it to me. You making the claim is not me denying it. It's asking you to prove
I'm just
your
surprised that
claim.
Right.
denying
In the
I'm
manner you're
theory.
talking
surprised that
about.
you would actually prove your claim. I don't know why you won't do that.
I'll pull up a video. Yeah, of course.
Let's just make
Okay,
it clear,
great.
Building 7, that we understand that light's capable of changing direction based on the environment, but we're asking you to demonstrate it in the form that you're specifically talking about.
Yeah, like the selenelian. I would like to see that.
Well, I'll try and pull up a video, I guess.
TW, you want to take over? I got to go.
Oh, yeah, sure, no problem. Man. Yeah, we got others here. Cyclone's just dropped in, so
Sweet.
Yep. He's good at he likes the discussion on eclipses. Unless he can't talk Cyclone, that's okay.
Did someone say my name?
Yeah, it says who's just talking to Building 7 here. They're currently discussing eclipses, selenelian, and I think that's right up your alley, isn't it?
Who is it?
Building 7. Oh, wait, is he gone?
Alright.
Wait, did he just take off? What
He's
the
already-
heck?
You already scared him off.
No way.
Boys got to slow roll it. He's going too hot, and they jettison. You got to trick them into thinking they're not going to get totally smashed.
He didn't want none of that cyclone smoke.
Obviously not. He must have saw it coming. Oh well, wake me up for the next one.
Name was
Okay.
Building 7.
He came down.
No one knows why.